Now we are very clear about classification, marking, and all. So what is classification? So there are different kind of traffics are generated by the user or the end user, the customer. Okay, he used to generate voice, video, data, WhatsApp messages, YouTube, actually, all kind of different applications traffic, different customer traffics are there. So these traffics has to be classified into the DSCP fields. How many DSCP fields are there? There are 64 different type of classes are there. So these different services, end applications or customers traffic are classified into 64 different classes. So that is called as classifications. So this is based on the some source and destination address, source and destination port numbers, and the type of protocol, higher order protocol carried over in the packet. And based on these things, the packets are classified. And once they are classified, they are marked. They are marked with the DSP. We will see that QCA in the later part. So it is marking is nothing but we are giving a DSCP value for each series. So that is called as the marking. Okay, then comes the policing. Policing, what the police will do? Actually, they will ensure that crime will not happen in the community. So similarly, none of the traffic flow will take an advantage over other traffic flows in this one. So it ensures that nominal average bit rate has to be followed up in the policing. Okay, for example, how this policing job will be done. For example, sometimes a busty of traffics will comes into the network. Sometimes there will be absolutely no traffic. Sometimes there will be an average traffic flow will following through that. So since the incoming to this policing is a different kind of traffic, we can't predict it. But in the exit, we have to give a nominal average bit rate. It may not be if we set with an average bit rate. Sometimes it will be overutilized. Sometimes it will be underutilized. So we have to adapt to the situations of the incoming traffic. So this is done by using two different algorithm, that is called as leaky bucket algorithm and token bucket algorithm. So this we have seen. I will give you a YouTube link where you can study about the leaky bucket algorithm and token bucket algorithm in the description. Okay, and the second method of policing is the CAR, committed information rate, and enhanced information rate. For example, the output of the policing link is the 2 Mbps link, which is connected to the internet. But incoming is 4 Mbps traffic is going on. So CAR, we are configuring two different values in the policing, CAR value and the EAR value. So for a CAR value at any given point of time, I am committing to the customer that 2 Mbps traffic will be flown through the internet world. So I am giving guarantee that any point of time I can carry 2 Mbps traffic. But if capacity is available in the egress, then I can carry additional traffic of the customer. Even though customer is subscribed to 2 Mbps line, if space is available, then additional 2 Mbps traffic also will be carried in the egress. So that is called as enhanced information rate. So these two values are configured in the policing part. Okay, then using these two algorithms, we have arrived at a nominal average bit rate. In that bit rate, it will traversing through the internet. Okay. In the policing part, we classified the packets into three different parts: green packets, yellow, and red packets. Green packets conform to the policies. Whatever policy is there, they 100% conform to the policies. Yellow packets almost conforms to the policy, and red packets not conforming to the policy. For an example, the egress is 2 Mbps line. So ingress is 2 Mbps. Then these packets are classified as green packets, and the egress is 2 Mbps, ingress is 3 Mbps. It's almost conforming to the policy. So these packets are confirmed as yellow packets, and the ingress is 4 Mbps and egress is 2 Mbps. This is not conforming to the policy. So these packets are marked as red packets. So there is a probability these packets will be dropped in the transport medium. Okay, so these are all the three different methods: classification, marking, policing has to be done in the ingress traffic. And what about in the egress traffic? Once in the egress traffic, we have to do three different things. One is queuing and scheduling and the congestion avoidance. Okay, we have to, for example, there are 6 different queues or 8 different queues are there in an equipment. Okay, so we need to push the traffic into the different queues. So on what basis we will push the traffic into different type of queues? That is called as a red and a W red. We follow these two algorithms, either of these algorithms, to push the traffic into the different type of queues. Okay, goes to one of the queues based on the DSCP values. So DSCP, if DSCP values changes, then queue also can keep on changes. Okay, if the queue is full, then tail drops will happens. So if it started randomly dropping the almost all the packets in the ingress directions. So in order to avoid that, we follow that red and W red algorithms. I have prepared a video for red and W red in a separate section because it's a separate topic. I will give you the link in the description also. So I have given the link for both leaky bucket, token bucket algorithms and red and W red algorithm. So, okay, using red and W red algorithm, we dumped the traffic and DSCP values based on DSCP values. We dumped the packets into the different queues, that is 8 different queues. Okay, now I have to vacate the queues. I have to take the packets from the queues and send it to the transport medium. So who will do this job? This job was done by the scheduler. So how the scheduler will do this job? Scheduler has its own algorithms. So it follows priority queuing, weighted fair queuing, and priority weighted fair queuing. So using either of these algorithms, it used to take the packets from different queues and send it to the a transport medium. And finally, congestion avoidance. So whenever we started dropping packets and queues are full, we send an explicit notification to the sender, hey, please calm down or slow down, I am full. So I will let you know whenever the packet is whenever there is a space in the buffer, you started sending the packets. So this is called as congestion avoidance. So if you are going to prepare a QoS script or a QoS policies, then what are all the things you have to capture in the QoS policy? Starting from the classification, you have to classify the packets and mark it using the DSCP values. You have to specify the DSCP values for different services, and you have to tell what kind of algorithm you have to use in the policing, either leaky bucket or token bucket algorithm, and you have to specify what is the CAR and EAR values in the policing. And then in the policing, you have to color the packets based on these things, whether they confine to the policy or not. You have to specify the green packets, yellow and red packets. And then we have to dump the packets into the queues using 2 different algorithms, red and W red. You have to specify which algorithm I am going to use, whether a red or W red, and then based on the DSCP value to queue mapping that has to be done, and then you have to vacate the queues using 2 different algorithms. Sorry, 3 different algorithms: priority queuing, weighted fair queuing, and priority weighted fair queuing. Using these, which one we are going to use, either of these 3 things, and that you have to specify in that. And then finally, we have to specify the congestion avoidance notifications also. So these are all the things should be there in your QoS set, QoS script. So finally, we come to a transport medium. Transport medium may have a different technologies. One Ethernet will be followed up in one segment. In another segment, MPLS will be followed. In the third segment, IP will be followed. So how I ensure that same QoS settings will be followed up in each technology world. So for example, in IP world, I follow the DSCP values, and similarly in Ethernet, there is a EXP bits are there, that is 3 bits. So DSCP to EXP mapping should be done whenever packets traversing from IP world to the Ethernet world. So similarly, if they are traveling from Ethernet world to MPLS world, in MPLS, there is a field called user priority, priority code points, PCP, that is 3-bit field. So you have to map EXP to PCP. And if it is going from IP to MPLS world, then you have to map DSCP to PCP bits mapping. So using these mappings, we can ensure the QoS is followed up from end to end in the transport network. So that's all users. For different kinds of algorithm which is followed in the policing and scheduling, please visit the link which is given in the descriptions. Thank you for your time. Have a nice day.